not using the altitude. Altitude, that thing that goes from a vertex to the opposite side at 90 degrees, we're not touching it. So we're not using the altitude. Are we going to end up using the L or the T?
L.
We use the L. Now it's going to look like a backwards L for us. We know we're going to use the L formula, okay? If we're just using the L formula, we're going to always have to start 90 degrees on the hypotenuse. All right, so we're going to start there. Get a full proportion up. We'll go, we know one piece to the left, we know two pieces to the right. We'll go to where there's more information. So I'll go 1, 2, 3, 4. Now the setup's pretty easy on this one. Start here, x plus 2, back over, x plus 2, and then all the way up. Now how big is all the way up? Don't say 5x. X plus 5. Thank you. Now, put your algebra hats on. You're going to need them. Cross multiply. What is x times x plus 5?
X squared plus 5.
X squared plus 5x. You have to distribute x times that, x times that. Now, x plus 2 times x plus 2. We get a FOIL. X squared plus 2x plus 2x. First, outside, inside, last, plus 4. Combining like terms, I end up at x squared plus 4x plus 4. Now we got to solve this thing for x. So we got to get everything, all of our like terms together, combine our x squared, combine our x's, combine our constants. Now, remember, how do I move this x squared from this side to that side? Subtract it. If I subtract an x squared from both sides, lucky for me, no more x squared. I'm left with 5x equals 4x plus 4. Now I just got a little two-step equation. Do one-step equation. What would you guys do next? Subtract 4x. I get x equals 4. That's not as bad as it was. 7 through 1. You want to see anyone in particular done other than number 6? 7. Okay, now think about number 7. Deal with one variable at a time. And the way they have this set up, we can solve for either one first. So which one do you want to solve for first? Solve for y first. Okay. So forget x is even over here. Now, we're going to solve for y. Are we going to use the altitude? Yeah, y is the altitude. And if we're ever using the altitude, we'll use what formula? The T. Now, you got to tilt your head to the side a little bit to see the T you're going to make. But whenever we use the T formula, we start not touching 90 degrees. We're on one of the corners, not touching 90 degrees. So I can start here. Or I can start here. Doesn't really matter. I'll start at the top. Make my T. 1, 2, 3, 4. Alright, so then when I fill it in, 6, y, 24. 6, y, 24. Again, it's got a proportion. How to solve proportions? Cross multiply y squared equals, I'm guessing that 144. Yeah. How do you unsquare something? Square root it. And y equals 12. Now, forget everything we just did. And let's solve for x. Let's solve for x. Now, if we solve for x, completely forget about that. Are we going to use the altitude when we solve for x?
No.
Nope, so we'll use the and start on the 90 degrees. Now, we know one thing to the right, we know two things to the left. So which way are we going to go first? Yeah. 6, x, what's that?
30.
30. Thank you very much. So 6x x 30. Add those together. Add those together. All right. So then I go through, cross multiply, I get x squared. And you know I don't like multiplying with numbers, get big numbers just to break them down again. So I get x squared equals 6 times 30. What gives me 30?
6 times 5.
6 times 5. Now I'll take the square root of that all day long. The square root of x squared is x. We take the square root of something. Look, I got 2 of those. Which means we're 1 on the outside, the 5 trapped in. Not too bad. A little better today. Think you can do 3 of them on your own? Grab a scratch piece of paper. Grab a piece of paper. If you want to sit by somebody, work with somebody, that's fine. I have no problem with that. It's technically 4 problems, but it's 3. I'll give you a hint on 3. A hint on number 3. You have to solve for x first. You can use like a little half sheet you can share with somebody, make a friend. You have to solve for x first on number 3. 3 problems, 5 minutes, doable? Yes, no? Maybe. Maybe? You do 5 minutes? You want to work with somebody, you want to compare answers with somebody, feel absolutely free to do so. close. Very good. Tired of doing all the work for you. You get to start out.
I'll do the second.
Sounds great.
I'll do me.
Got X on the third?
Yeah.
Just do this whole third one like that. You can change colors if you want, just
Okay.
tap whatever one you want. Yellow's hard to see.
Okay, I'll do some.
Six over X equals X over 12. Squared equals 6 times 12, which is really 6 times 6 times 2, I agree. White Lake received choked out. Labeled January 6th. It's good, but it's very good. No. Not using the altitude, so we'll go for the L. 4 over X equals X over 12. That 12 is where you're going to make your mistakes. Remember, you add the whole bottom. Don't just leave an 8 there. Careful, you just divided by 2. You got to take the square root. So you're going to think, oh, let's break out 48. This is 48.
1, 4.
So, cut 48. Square root is 16 times 3. So we break down 16 times 3. Square root of 4. What is the square root of 4? Yeah. There we go. 4 out of the 3 looks fantastic. Everly. Questions like number 3. I'm going to stop giving the hints. You eventually going to figure out what you got to solve for first on your own. 5 over 10 equals 10 over x. Very good. Easy little cross multiplying. 5x equals 100. X equals 20. Then you've got to plug in 20. You got to use that 20. Y. Use the L formula. Break it down so they get the big numbers. Got 2 5s. Square root of 4 is 2. Beautiful. Said you got to do my job more often. Alright, we'll do a couple of those beginning class next couple of days. Just get used to it. It's something weird. I understand that. But we're going to move on today to a very easy addition to the... Where am I going? I'm going in... Yeah. Very easy addition to our repertoire, because you guys I guarantee have seen this. We're going to talk about the Pythagorean theorem and its converse. I remember converse is just doing the same thing backwards. Normally, everything we do forwards is going to work just as good backwards. The converse of the Pythagorean theorem is no different. What are we actually going to do today? Get these written down. I'll give you a little bit of time. We're going to use the Pythagorean theorem. Some of you guys can probably already say it because you guys have used it. It's going to look very familiar. I don't need those two problems just yet. We use the Pythagorean theorem, and we're using the converse. You can say use the Pythagorean theorem and its converse. Save some writing. I'm fine with that. Because the converse is all that different from what we're really doing. It's just more of a proof. Anybody, I know somebody in here can. What is the Pythagorean theorem? Remember that back page of your notebook that I said you put the most important things on so you know right where it's at? Then we got the slope formula, the midpoint formula, the distance formula in there already. Ooh, have we already put the Pythagorean theorem in there?
Yeah.
First one we did, nice. We're going to use it a bunch. We're going to talk about it a bunch. Later on, we're going to be doing these super hard problems, and eventually you guys are going to realize I could have used the Pythagorean theorem 5 minutes ago, saved myself a ton of time. It's a time saver because it's so easy to deal with. Use the Pythagorean theorem in the converse. Are we going to yell when we switch? Alright, Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the legs. So through all this, we need to talk about a couple things. First thing, hypotenuse. Where is the hypotenuse always located? It's always C. It's always the longest side. It's always across from the 90. Has to be across from the 90. Has to be across from the 90. What are the legs? A and B, they're the, well, for lack of better terms, they're not the hypotenuse. They're the other parts of the triangle. So just don't get confused if we start talking about the legs and the hypotenuse. Just realize legs are touching the 90, hypotenuse across from the 90. And the big thing with the Pythagorean theorem that I want you to write down, C is the hypotenuse. Every time, no question asked. The hypotenuse has to be C. It doesn't matter what leg is A, it doesn't matter what leg's B. I mean, your longer leg doesn't have to be A, your shorter leg doesn't have to be B. You can switch your legs around back and forth all day long, but your hypotenuse has to be C. And it has to be the largest side. That's going to come into play when we talk about the converse. Your hypotenuse has to be the largest, biggest number. Good job. So we can talk about this, and you can use it to find a whole bunch of stuff. They're talking about latitude and longitude. It says Carson City, Nevada is located about 120 degrees longitude and 39 degrees latitude. And NASA Ames is located about 122. That's all a bunch of numbers trying to screw you up. Look at the pictures, which is very nice. Use the lines of longitude and lines of latitude. Help me out. What goes horizontal? Longitude horizontal? That's more of a question. Yeah? So the nearest tenth of a degree if you were to travel directly from city to city. Okay. Here's what it basically says. It's not going to show up. How far is it from here to here? By the lines of longitude. 2. How far is it from there to there? Is it? 1 2/3. Fraction. We'll start the whole time to do this. Start off with the fraction. Let's do it this way. Latitude. Latitude 37. Latitude 39. By this is 2. Our picture's off. The latitudes are 2 off. The longitudes are 2 off. So we got a 2 by 2. Now this is, we're going to assume a 90-degree angle. So we have a right triangle. Right triangles are cool. You can use Pythagorean theorem. Do I know the legs or the hypotenuse? I know both legs. So in my a squared plus b squared equals c squared life, do I know A, B, or C with these two twos? I know A and B, so I'm going to plug them in. 2 squared plus 2 squared equals C squared. Now, that means C has to be the H word. This also means it has to be what in 2 and 2? It's got to be larger than 2 and 2, so let's talk about it. What's 2 squared? 4. What's 2 squared? What is it? Tough math we're starting with today. 4 plus 4. 8 equals C squared. Nah, think about it. You have to unsquare something. Square root it. We get the square root of C squared is C. Square root of 8. What's the perfect square of 8? 4 times 2. What's the square root of 4? What's less than 10? I'll tell you right now, this answer I love. This answer, 8. Don't run to your calculators and start giving me decimals. I'm going to count them wrong. I want reduced radicals. We can do it. We're going to brag about it and do it all the time. So let's do another one. Like this one. Look at that. It's going to make me sick to even watch. You know why I don't like this? Notice the extreme difference from there to there. What's this mean? Equals. Equals. Approximately. Here's the problem with approximately. So it's approximately 2.8. That's great. When we start cubing stuff, approximations triple. You end up with these huge differences in answers. I don't like approximations. We start cubing square roots. Yes. Don't give me decimal again. But watch how we do this with B. Find the third side. Okay, so the thing you have to ask yourself at the beginning of every one of these problems, do I know A, do I know B, do I know C? I know A and C. So right now I know that it would be 3 squared plus B squared equals C squared. Don't make this mistake. 6 squared minus 3 squared is 3 squared. Don't do it, it doesn't work. 3 squared? 9. B squared, B squared, 6 squared, 36. Look at the two-step algebra equation. Next step. Tell me. Subtract 9. 36 minus 9, not 25. 27. Alright, I have a b squared. I have to unsquare it. The opposite of squaring. Square root. Square root. Perfect square times 27. 9 times 3. Reduce it for me. 3 radical 3. Pretty simple. Feel confident and know we can do this? What 2 letters do I know? A and C. Could I know B and C? Yes. Does it matter if I know A and C or B and C? No, not at all. So I'm just going to go A squared plus what? 8 squared equals C squared. Alright, 8 squared? 64. 15 squared? 225. 60 or 2 225 minus 64. Grab calculator if you need one. Type your own word. 160. What goes into 161? Did I start with the 225? No. Square root of 161. Does anything go into 161? Does 2 go into it? You guys remember the rule? Like 2, they're even, it'll go into it. 3, the numbers in there will add up to a multiple of 3. So like 1 plus 6 plus 1, that's 8. That's not a multiple of 3. So 3 won't go into it. 4, I can't remember. 5, is it 5 or 1? 6, 2, and 3 both go into it. 7, I can't remember.